Good morning, students. Welcome to video lecture class on dynamics of machines. So we'll start with the problems on forced vibration. So we'll start with the first problem. The statement of the problem is a mass of 10 kg suspended from one end of helical spring and the other end is fixed. The stiffness of spring is 10 Newton per mm. The viscous damping occurs the viscous damping causes the amplitude to decrease 1/10 of initial value in 4 complete oscillations. If the periodic force of 150 cos 50 t Newton is applied at the mass with a vertical direction, find the amplitude of forced vibration. What is its value at resonance? Remember, before starting the solution, first you need to understand the given statement, and then you need to identify the given data. Then you have to identify what are the things you need to calculate. So first we'll try to list out the given data. So here he has given that a mass of 10 kg means M, he has given 10 kg is suspended from one end of the helical spring and other end is fixed here. The stiffness of the spring he has given, that is K value he has given. So he has given it as 10 Newton per mm. So we need to convert this one into Newton per meter. So it will come 10,000 Newton per meter. Okay. And it is a viscous damping. The amplitude to decrease 1/10 of its initial value in 4 complete oscillations. That means the number of oscillations are 4, and it will decrease its value to 1/10 of its initial value. So for example, at the 4th cycle or 4th oscillation, if I take the displacement as x4, so the value of x4 will be 1/10 of initial value, that is x0. And applied force function is f of t he has given as f0 into cos omega t. If you compare with that one with this given, that is 150 into cos of 50t, we will come to know what is f0 and what is omega value. Okay. And he asked us to calculate the amplitude of forced vibration and what is the value of amplitude if the system is at resonance. So first we will try to calculate the amplitude of forced vibration. So f of t equal to f0 into cos of omega t is the standard format or standard form of the forced function. Okay. So if you compare this given force function with this standard one, you will come to know f0 is 150 Newton and here it is cos omega t and here it is cos 50t. So omega is 50 radian per second. So now we'll try to calculate the undamped natural frequency with the help of given mass and spring. Okay. So omega n equal to, as we know, it is given by root of k by m. K value is 10,000 and m is 10. So we will get it as 31.622 radian per second. Once we know the value of omega n and already omega he has given, so we will calculate the frequency ratio, that is R, which is equal to omega by omega n. So where omega is 50 and omega n is 31.622. So if you substitute that, you will get the frequency ratio as 1.581. Now here he has given one condition that there is a 4 complete oscillations. So x0 by x4 will be the ratio, displacement ratio. So we can rewrite that one as x0 by x1, x1 by x2, x2 by x3, x3 by x4 put together. We can write it as x0 by x1 raised to 4, because here all the amplitude in all the cycles is same. That is x0 by x1 equal to x1 by x2 equal to x2 by x3 equal to x3 by x4. So we can write the equation as x naught by x1 raised to 4. So which is equal to x naught by, here that final value will be 1/10 of initial value. So if you equate those two, you will get it as, that is x naught as it is, x4 as 1/10 of initial value, which is equal to x naught by x1 raised to 4. So from this you can get the ratio of x naught by x1 as 10 raised to 1 by 4, which is equal to 1.7783. Now with the help of this, we can use the logarithmic decrement equation, delta equal to ln of x naught by x1, as you already know. So which is equal to ln of x naught by x1, you have calculated here it as 1.7783. If you substitute that, delta value will be 0.5756. For the same logarithmic decrement, we are having one more equation, that is delta as 2 pi zeta divided by root of 1 minus zeta square. So if you substitute here, you know the value of delta, only zeta is going to be unknown. Substitute the value of delta and simplify to get the value of zeta. So we will get the zeta as 0.091235. So why we are calculating this zeta? In the amplitude equation, we need that zeta and frequency ratio. Okay, then after that, the amplitude of forced vibration, that is x max, is given by x naught divided by root of 1 minus r square whole square plus 2 zeta into r whole square, where this r is omega by omega n, and where this x naught is the zero frequency displacement, which is given by f naught by k. F naught he has given and k he has given. So from that easily you can calculate x naught as 0.015 meter. So if you substitute this x naught value and r and zeta in this equation, you will get x max, that is maximum amplitude of vibration, as 9.82 into 10 raised to minus 3 meter. Now moving further, the second bit he has asked us to calculate the amplitude when the system is at its resonance. So at resonance, as we know, omega equal to omega n. So the amplitude of forced vibration, that is the same equation if you want to use, this x max will become x naught by 2 zeta. Already I have calculated x naught and zeta. So if you substitute that, you will get the maximum amplitude as 0.0822 meter. So this is the complete solution for the given problem. Now we go for the second problem. Here is the statement: a refrigerator unit having a mass of 35 kg is to be supported on 3 springs, each having a stiffness K. Unit operates at 480 rpm. Find the stiffness value K if only 10% of the shaking force is allowed to be transmitted to the supporting structure. So this problem is based on the transmissibility ratio. Okay, so based on the given data, you have to identify which formula you have to use. So as we know that the transmissibility ratio is given by the ratio of force transmitted to the force applied, Ft by F naught. So, and he has given that M as 35 kg, and he has given that number of springs are 3, and he has given the speed N as 480 rpm, and he has given that only 10% of the shaking force is allowed to be transmitted. That means the amount of force which is going to be transmitted is only 10% of the applied force or shaking force. So that is Ft equal to 10% of F naught. So if you substitute this Ft equal to 10% of F naught in this transmissibility ratio equation, you will get transmissibility ratio as 0.1. Now with the help of given speed, we can calculate the circular frequency of forced vibration, that is omega. omega equal to 2 pi n by 60. So in place of n you have to substitute 480 rpm. Don't get confused with this omega calculation of omega and omega n. Omega n is different, omega is different. Omega is a circular frequency of the forced vibration and omega n is the natural frequency. Okay, so if you substitute n as 480 rpm, you will get omega as 50.2655 radian per second. So when he has not given any information about the damping, so we can treat it as there is no damping. That means we have to take that zeta as 0 in this case. Only when in the given statement, if there is no information about the damping coefficient or damping factor or critical damping coefficient, so that time directly you can assume that there is no damping. So if you take the transmissibility ratio equation, it is given by 1 divided by r square minus 1. This equation is only when there is no damping. So where r is omega by omega n whole square. So if you substitute in this equation, you know omega and you know transmissibility ratio, but you don't know omega n. So you have to use this equation to determine the value of omega n. So if you simplify for omega n, you will get omega n as 15.1556 radian per second. And omega n, as we know, we have the common equation as root of Ke into Ke divided by m, where this Ke is equivalent stiffness because there are 3 springs as given. So we can, in place of K, you have to write it as Ke. So in this equation, you know omega n, we already calculated, m he has given, so only unknown is going to be Ke. So simplify to get the value of Ke, so that you will get Ke as 8039, that is 8039.24 Newton per meter. So if the springs are arranged in parallel, then the stiffness of each spring K equal to Ke by 3. So the stiffness of each spring is 2629.75 Newton per meter. If there are springs are in series, that time the stiffness of the each spring will be different. So in this statement he has given that the springs are arranged in parallel, so we can write the stiffness of each spring as Ke by 3 because this 3 is number of springs which he has given. Then moving further, the third problem, a machine of total mass 17 kg is mounted on springs having stiffness of 11,000 Newton per centimeter. A piston within the machine has a mass of 2 kg, has a reciprocating motion with stroke 7.5 centimeter and speed as 6,000 rpm. Assuming the motion to be simple harmonic motion, determine that first one amplitude of machine, second one transmissibility, third one force transmitted to the ground. So and take zeta as 0.2. As I said in the previous problem, here he has given zeta value directly. Sometimes he may give you the damping coefficient value. Okay, so in previous problem he has not given any information about the zeta or damping coefficient, so there we assume it as a undamped system. Then we have taken it as there is no damping in the system, but in this case we cannot avoid the damping factor. Okay, so first we'll try to list out the given data. He has given that machine mass as 17 kg, spring stiffness as 11,000 Newton per centimeter. You need to convert that one into Newton per meter, which will be 11 into 10 raised to 5 Newton per meter, and he has given the mass as 2 kg. Okay, piston mass as 2 kg. Then he has given speed as 6,000 rpm and the damping factor as 0.2, and it is a reciprocating motion with a stroke of 7.5 centimeters. So here is given the total stroke length. From that you need to calculate eccentricity value, that is E equal to half of that you have to take 7.5 divided by 2, which will be 3.75 into 10 raised to minus 2 meter, because here it is in centimeter, that also you have to convert into meter. So here it is a reciprocating motion. Okay, for that reason this E is existing in this problem. Okay, then the circular frequency of forced vibration, once you know the speed in RPM, omega you can calculate, omega equal to 2 pi n by 60. So 2 pi into 6000 is the speed which he has given. You substitute that, you will get omega as 628.32 radian per second. Then the undamped natural frequency, as you know, omega n equal to root of k by m. So here also you know the value of k he has given, and m is known, 17 kg. If you substitute those two values, you will get omega n as 254.37 radian per second. Once you know the value of omega and omega n, you have to calculate frequency ratio, that is R, which is equal to omega by omega n. By substituting those two values, you will get R as 2.47. Then you need to calculate, the first bit is maximum amplitude of vibration. So remember, in this module, if you want to solve any problem, first you should have omega, omega n and frequency ratio. If there is a damping, you should know the value of zeta. Okay, so then only you can use the amplitude or the maximum displacement formulas, or you can use the transmissibility ratio formulas. Otherwise you cannot use, because these formulas contains only three terms: omega, omega n and zeta terms. Okay, so first with the help of given data, try to determine those values. After that you start calculating the what are the things he has asked. Okay, so the first one is maximum amplitude of vibration. So which is given by, for the reciprocating system, x max equal to m by m into E into omega by omega n whole square divided by root of 1 minus omega by omega n whole square plus 2 zeta into omega by omega n whole square. Wherever omega by omega n is there, you can substitute it as R. In terms of R, you can remember the formulas. So in this equation, we know all the values. Substituting all these values, you will get maximum amplitude as 5.18 into 10 raised to minus 3 meter. See, all the formulas are similar, but only based on the given type of the system, little bit variations will be there in your formulas. Because here in this problem, he has given that it is a reciprocating system. That is the reason why here you are having m by m. Otherwise it would have been me into omega by omega n whole square for the rotating systems. Please remember that. Then the transmissibility ratio TR is given by 1 plus 2 zeta into R whole square divided by root of 1 minus R square plus 2 zeta R whole square. So here also we know all the values. Substituting those values, you will get transmissibility ratio as 0.27. Similarly, for the third one, force transmitted to the ground. So he has asked us to calculate Ft, but we know that the transmissibility ratio is given by Ft by F0, where this F0 is the impressed force for this reciprocating system. We can calculate it as m into omega square into E. So here we know the value of m, we know omega square, and we know omega value, and we know E value. So substitute in place of F0 as m omega square E, and you know the TR, that is transmissibility ratio, which you already calculated. So in this entire equation, only unknown is going to be your Ft. So if you solve for Ft, so the transmitted force will be 7,994.4 Newton will be the force transmitted to the system. Okay, so here to solve the problems, the first thing is you need to understand which type of the system he has given, whether it is rotating or reciprocating, or whether it is based on the transmissibility ratio. These all things you can judge only by observing the given data. Okay. After that, before using any formulae, you should know the value of omega n. With the help of those two, you have to calculate R value. Then you should know the value of zeta. Sometimes he will give you the zeta value directly, or otherwise, as we have solved the first problem, there he has given some information about the oscillations. Okay. So with the help of those oscillation information, we have calculated first logarithm decrement. With the help of that logarithm decrement, we have calculated the zeta value. So once you know this omega n and zeta, then only you can use these formulas. So we'll conclude the today's session here itself. So in the next class, we'll try to solve few more problems on this chapter. If you have any doubt, you can leave the comment in the comment box. Thank you.